Hello and welcome everyone. Thanks for spending your lunchtime with me. My name is Marco Abela. I am a Principal Product Manager at Dell EMC, specifically working on the XtremIO product line. What we're here to talk to you about today is Metadata-Aware Replication, which is a new unique technique for efficiently delivering business continuity and disaster recovery. Very different and much more efficient from any other storage replication solution out today. Just by show of hands, how many folks here have XtremIO today or are familiar with XtremIO? So about half. Okay. So let's start by saying that replication by definition is the copying of data and no other storage. So in fact, it's actually a copy data problem. And no other product handles copies of data better than XtremIO. Traditional replication solutions, they rely on brute force copying of data in order to do the replication. This forces administrators to have to make trade-offs between RPO and RTO and cost. So the higher the level of protection, obviously it comes with a higher cost. What you see with existing replication solutions is that they are not very efficient in the way that they do replication. So what you typically see with existing replication solutions is that all changes need to be replicated. Arrays at both ends need to transmit and receive all change data. There's no awareness between the two sites. WAN bandwidth needs to be sized to account for all change data, and many customers have to, in fact, deploy very expensive WAN accelerators in order to reduce the bandwidth. So in this particular example, we're looking at an existing replication solution where we have a primary site replicating to a DR site, so a source replicating to the target. The source and the target are currently in sync with these three data blocks A, B, and C. And what happens is, let's say a new data block is written. Even though this is a duplicate data block at the source and at the target, this data block A already exists at the target, but the two arrays are not, they don't communicate, and they're not able to know that this block already exists. So we actually have to use up bandwidth over the link in order to do the replication. Now, yes, some of the more modern storage arrays today have deduplication, where the data block would have been deduped at the source and then again at the target. But that deduplication would not take into consideration the WAN, the links. That block would still be sent over the WAN, and then once it arrives on the target, it then gets deduped. But again, from a WAN efficiency standpoint, it's not very efficient. The difference with XtremIO is in using the metadata awareness of XtremIO, where the source is fully aware of the content of the target, where if a data block already exists on the target that needs to be replicated over, we do not need to do that. We can do it in a much, much more efficient way, simply by replicating only the metadata. So same exact example as I was showing before. We have a source site replicating to a target where the source is currently in sync with data blocks A, B, C, and D. If a duplicate data block or a new data block comes in that needs to be replicated, same exact example as before, this is a duplicate data block. Data block D gets written. The source knows that this data block already exists on the target and it does not need to replicate it. It simply sends over its hash metadata, making it much, much more efficient, both from a storage perspective and from a bandwidth and link utilization standpoint. So what you saw in this example right here is that with the XtremIO's metadata-aware replication, only unique changes are replicated, so data is deduped at the source, destination, and more importantly, over the WAN. And the unique data blocks that do in fact need to be sent over, which I'll show you more later on, are done so in a compressed manner. The arrays at both ends transmit and receive only the unique data, freeing up the resource for other use. WAN bandwidth needs to be accounted or sized to account for only globally unique changes. In some cases, actually eliminating the need to deploy any WAN accelerators. I'll show an example of that later on. And you can free up this bandwidth for other applications, or you can actually increase your RPO or replicate other data that you previously weren't able to replicate before. Now let's see where this metadata awareness actually shines. So XtremIO's Metadata-Aware replication also supports a fan-in configuration of 4:1, where 4 single source arrays can replicate to a single target. So in this particular example, we have the 5 arrays are fully in sync with data blocks A, B, C, and D. And again, any of the 4 source arrays are fully aware of the content at the target array. So let's say that site 2 writes a new data block. In this case, it's data block E. Even though this data block is unique to site 2, if any of the other sites were to write this same exact data block E, even though it is even unique to these other sites, these sites check with the target before beginning the replication cycle, and they know that this block already exists, so they do not need to replicate this over. So in this particular example, again, you're saving, by doing a fan-in configuration, everything is deduping against each other, so you're saving both from a storage perspective and from a WAN utilization perspective. What XtremIO's Metadata-Aware replication allows you to do is replicate high change rate workloads driven by all-flash array performance while maintaining great RPOs. We actually support an RPO of as low as 30 seconds without breaking the bank on WAN upgrades. You can do 4:1 fan-in configuration where you're benefiting from global dedupe across all the single sources and at the target. Again, saving both from storage at the target and WAN utilization. And you can make choices like getting the existing replication job done in the same amount of time using less bandwidth and therefore reducing your overall costs. Or you can increase the amount of data that you're replicating using the existing WAN bandwidth that you have while increasing your overall levels of protection. What XtremIO Metadata-Aware replication allows you to do is protect your workloads in the most efficient way possible. So it uses XtremIO virtual copies, which I'll explain a little bit later on, and a wizard-based GUI for easy setup and full operational disaster recovery. It supports an RPO of as low as 30 seconds, allowing you to recover from up to 500 different recovery points with a sub-minute RTO. Actually, from a storage perspective, it's actually in a 0 RTO. We support a fan-in configuration of up to 4:1, as I showed before. From a performance standpoint, it's built around being able to support the high-performing use cases that XtremIO supports today, with efficiencies that include being both dedupe and compression aware. So you keep hearing me mention this metadata-aware replication. So what does that really mean? Before we do that, let's take a look at some of the architecture of XtremIO, specifically in it being referred to as CAS, Content-Aware Storage. What content-aware storage means in the perspective of XtremIO is that as an incoming data block comes in, we create a hash of that data block, and we keep it in memory. For every single data block, we have this mapping of a hash to where it's actually stored in an SSD perspective. If a duplicate data block comes in, it means it will simply result in a duplicate hash, and we can simply dedupe it in memory. So as you can see, as a part of this, deduplication is simply a byproduct of doing the content awareness of XtremIO. So it allows us to do deduplication very, very efficiently, always on and in memory. Next, let's talk about XtremIO virtual copies. So XtremIO virtual copies are very different from any other copy or snapshot solution available in the industry today. And what you have, the reason why is with the traditional snapshots, there's a lot of baggage associated with them. So first, they're never immediate. They take up some time. Second, they're not very space efficient. So best case scenario, you're only copying metadata. Worst case scenario, you're copying both metadata and doing a bit for bit copy. And last, you never get the same performance as the original source volume. In some cases, it actually negatively impacts the performance of that source volume, where as long as you have this copy created and mounted, it will actually negatively impact the performance of the original source. With XtremIO virtual copies, it's completely different than any of that, and it has no baggage associated with it. So first, the snapshot operation is absolutely instantaneous. Second, it's both space efficient and metadata efficient. even when mounting a snapshot, we are never copying any metadata or any blocks at the SSD layer. And last, we don't really distinguish between a source volume and a snapshot, or a production volume and a snapshot, other than a little icon in the GUI. For us, they're treated exactly the same, where the snapshot gets the exact same high performance as the original source volume without negatively impacting that source volume. And this is exactly what this shows. So this is XtremIO virtual snapshot versus a traditional snapshot implementation, which what you can see is that in this is that at the moment that a snapshot is taken, the performance of that original source volume starts to go completely wild and becomes unpredictable. In that case, where it's actually getting performance that is really, really very, very bad, to the point that it's not even behaving like an all-flash array, it's actually getting the performance of a spinning hard disk drive array. With XtremIO, again, we have no performance penalty when you take a snapshot, neither on the source or the snapshot volume. Another great feature of XtremIO virtual copy technology is that we provide you the ability to instantly refresh or restore any volume or snapshot with any other volume or snapshot within its tree. So I can take a snapshot of a snapshot of a snapshot, and I can refresh between the snapshots. I can refresh back to production, or for production, I can pick any specific snapshot to refresh to. The possibilities are really endless. But you can do all this, all these refresh operations while keeping the same SCSI face. So that means you don't need to do a host rescan, which usually takes some time, which I'll explain to you soon why this is very important and enables a very fast RTO from a replication standpoint. So put them all together and you have the basis for our replication solution. So first we begin by only replicating change data blocks. So in this example, again, we have a source array replicating to a target. And the first step in beginning the replication cycle is getting the source in sync with the target. So we create a snapshot to do the initial sync. We remove any duplicate data blocks, and then we send that snapshot over as a fully recoverable point in time. Then, based on the user-defined RPO, so again, we support an RPO of as low as 30 seconds. So let's say that the next cycle kicks off 30 seconds later. We take a snapshot, and we do a snap diff operation, which basically analyzes any changed data blocks from the current snapshot to the snapshot 30 seconds ago. So it's kind of like right folding. Rather than have to replicate all the different changes, we only replicate the latest ones. Then, once we've done the snap diff operation, we send that snapshot over, which again becomes a fully recoverable point in time for you to do a failover to. Now let's take a look at how the efficiencies come into play. Again, we have a source replicating to a target where the source currently has data blocks A, B, C, D, and E. At 12, we do a snapshot for the initial sync to move these exact data blocks over to the target, where now we have the source in sync with the target. The source volume is your production volume, so obviously it's changing, you're writing data to it. So let's say that it writes brand new data blocks, D, F, B, G, and C. And at 12:05, we kick off the first replica cycle. So in this example, the user specified their RPO is 5 minutes. So again, what we do is, as part of the first replica cycle, we take a snapshot. We do a snap diff to analyze any changed data blocks from the current snapshot to the one 5 minutes ago. In this case, it's again those data blocks D, F, B, G, and C. Next, the source checks with the target to see if any of these data blocks are unique or already exist at the target. In this case, data blocks D, B, and C already exist at the target, so they do not need to be replicated. And last, the unique data blocks, which are blocks F and G, are compressed, and then the replication cycle is completed. Again, replicating all these data blocks and making that full volume available as a point in time for the user to recover from. So with this, what you can see is that the Metadata-Aware replication solution for XtremIO truly is the most efficient storage replication available in the industry today. From a failover perspective, I'll show you how it works. But first, you need to recall what I was mentioning before. Part of the flexibility with XtremIO virtual copies is the ability to instantly refresh or restore all while keeping the same SCSI face. So in this particular example, let's say the production site goes down, and at the DR site, I have 4 different point in times that I want to recover from. At the DR site 2, I have my the failover volumes already exposed and mapped to my host. So all that needs to happen is a refresh operation of the point in time that I want to fail over to, handled internally as a refresh operation to the host. So what happens is when I pick the point in time, we simply do the XVC refresh operation, which is instantaneous, which simply refreshes the content of the mapped volume to the point in time, again, without needing to do a host rescan. So from a storage perspective, the RTO is instantaneous. It's really, from a user perspective, how fast you can bring over your application over on the other hosts. So really, the architectural advantages of XtremIO in being content aware really lend itself to replication efficiencies in the solution. So what we have, again, is first we replicate changes only. We benefit from right folding. Again, we don't need to replicate all the change data. We only replicate the change data blocks that happen at the end of each cycle. We have global across-site deduplication, where again the source is fully aware of the target. If a data block already exists on the target, we do not need to replicate it over. This is what truly makes the solution unique. And last, the unique data blocks that do in fact get replicated over are done so compressed. So let's take a look at how this benefits the solution from a performance standpoint. So this is a single XtremIO X brick using 2 replication ports, so 2 of the 10 gig base T interface, where theoretically the max throughput that you can get with this is about 2 gigs per second. So here we've ran tests across 4 different latencies. So one is at 0 millisecond latency, which is replication within the same data center. Next is at 40 millisecond latency, which is, to give you an example, is intra-Europe replication, or from a US perspective, it's from Seattle to Chicago. Next is at 80 millisecond, which is US East Coast to West Coast, or Europe to North America. And last is 200 millisecond latency, which is intercontinental replication. So what you can see as part of this is that we're very close to reaching the theoretical limit of the 2 gigs per second from a average throughput perspective, but also as we are increasing latency, we are really getting almost no penalty in terms of throughput because of the way that the replication solution works. Now imagine that you're able to get 4-to-1 dedupe across the link. That means that your WAN bandwidth is actually just multiplying by 4x. So again, you're getting much more efficient replication solution at much higher throughput speed. Again, all made possible by this, the replication of metadata rather than just sending over the full data blocks. From a VMware standpoint, we have full integration with VMware's SRM through an SRA adapter. And one of the really cool, unique things that we offer is the ability to pick our recovery point from SRA. So for SRM today only allows you to fail over to the latest point in time, which is actually kind of backwards thinking, because if you have some type of data corruption, or for example you have a virus with a very low RPO, that same data corruption is going to get replicated over to the target site. So if I only have the ability to fail over to the latest point in time, that same exact corruption is going to happen at the target at the DR site as well. So with our VSI plugin, which is a free plugin which exposes storage functionality over to VMware from a vSphere perspective, you can actually go ahead and trick the SRM to actually fail over to a specific point in time that you can select. So this is a very unique implementation that we have with SRM that's available as part of this replication solution. So in summary, with XtremIO's Metadata-Aware replication, it plays around the theme of XtremIO's being a consistent and predictable storage array, and the same with all the data services. So first, it's very, very efficient. In fact, it's the most efficient storage replication solution available in the industry today, where we only send unique data to minimize WAN bandwidth requirements. And again, the source is fully aware of the content of the target. You can have four source arrays replicating to a single target, where all 4 of those arrays are fully aware of the target, never needing to replicate duplicate data blocks. It's consistent with minimal to no performance impact with a scale-out architecture that is XtremIO, allowing you to add compute as you're scaling with capacity. And it's extremely reliable with fast recovery across sites, supporting an RPO of as low as 30 seconds. With that too, with all the Dell EMC storage arrays, we have the future-proof program, which basically is a type of guarantee allowing you to have faith, basically show commitment in your investment. So we have a 3-year satisfaction guarantee, a hardware investment protection plan, which will buy back existing hardware for refreshes at a very, very competitive, from a very competitive cost. We have predictable support pricing, where you can lock in your maintenance at day 1, locking it for the lifetime of the array. A 4-to-1 all-flash storage efficiency guarantee, where we'll actually guarantee you that you're able to achieve at minimum 4-to-1 efficiency with your storage arrays. We have never worry data migration, which is also very good, because from a hardware upgradability standpoint or tech refresh standpoint, we'll actually guarantee you the ability to easily migrate to these new generations. And we also have all-inclusive software, where any of these features with XtremIO, the deduplication, compression, and even the native replication feature, it's available at no additional cost. It's simply a data service that's built into the DNA of the array. So with that, thank you very much. I'm available to take any questions if anyone has any. Thank you.